going to take a second, but what I'm going to do is go through this sequentially, test 1 to test 2. All right, how many in this room have this test? First page will tell you. All right, about half. So let me go through it with you real quickly. What it amounts to is I have a circuit where I have J5 here, J3 is the mutual, and J6 here on the secondary. So I make my V1 here, and I say V1 is equal to J5I1 plus J3I2. All right, now I turned I2 around here on purpose. In the second one, the I2 is coming out of the terminals. I on purpose turned it around, and I know that the actual I2 I'm going to include in the answer will be negative that. You follow me, everyone? Isn't that hard at all? So when I do this, there's V2, this is V1, and V2 is just J6I2 plus J3I1. I know I put that last usually, I'm just putting it there, it doesn't matter the order for this problem, okay? Now once you do that, I start here and I'm going to go around this loop. So I have an increase of 12 volts. Does everybody see if I go clockwise, I get an increase of 12. Then it's minus the impedance. The impedance itself is minus J4. Then it's going to be minus V1. And this is V1. So now I substitute in V1 here. And when I do that, I would get 12 minus J4 I1 minus a quantity this right here. But since I take 12 to the other side, it becomes minus, then I get rid of the minuses. I end up with this being a plus, this being a plus, and this being a plus. Does everybody follow me what I'm doing here? This is just simple bookkeeping. I'm organizing. Then after that, I get the coefficients of I1 and I2 and set it equal to 12. Now this is just simply organizing things the way you need to for a matrix solution. Does everybody follow me? After that, now I go around the second loop here. I've got minus 12 I2, so I'm going counterclockwise. Do you all see this? And then it's minus V2. Does everybody follow me on this? Got it? Did you have a question?
Yes.
Oh, I'm so sorry. I'm trying to. I'm so sorry. Let's see if I can do this. That should do it right there, right?
Perfect.
Please let me know for whatever reason, because I'm not looking at that, but I maybe should. All right, now when I do this, I'm going around, I get a minus 12 I2 minus V2. If you do it orderly like this, it's hard to mess this up. Organization is a big thing about being an engineer and bookkeeping. This is a bookkeeping problem. After that, I put in what V2 is, and V2 is this, so, by the way, right here I get rid of the minus signs, and then I get 12I2 plus J6I2 plus J3I1, then I simply organize this, right? Correct, class? After that, now I put it in a matrix form. My A matrix will be J, J3, J3, and 12 plus J6. This is just organizing the A matrix. The B matrix is 12 and 0, and then I is inverse A times B. Now, I1 is correct in the problem, so this is the I1 class. Agreed, class? I2 will be minus my I2. And by adding a minus sign, it adds or subtracts 180 degrees to that angle. Do y'all follow me that, class? Or you can actually put a minus sign there if you want. Either one is correct, but this is the answer, all right? This is the minus step. And it's nothing more than a simple, straightforward matrix problem, making sure you go around the loops right and know exactly how to draw it. It wasn't meant to be hard, it was actually a homework based entirely on a homework problem. With one exception, I think the homework problem had more, it had a different element added to it. There was another element that was removed. All right, now the other problem on the other test, how many had this test? You had that one of the two. Right? For this test, what happened? Well, I had to, I'm going to say my I2 is going to go in there, my I1 goes in there, the way I've done all the time. After that, I'm going to go around this loop. First for V1, pardon me. V1 is itself right there, J1 times I1, plus J1 times I2, because the mutual is J1. V2 right here is going to be J2 I2. Again, I make I2 coming in there. Follow me, class? I want to make sure that this is for the coupled circuits. I always going in. If they want I coming out, throw a negative sign in front of it. That's it. When I do that, my first one is going to be 10 minus I1 minus 1 I1 minus V1, that's V1. So I take 10 to the other side, make it minus 10 on that side. Then I multiply through by a minus sign. Everybody agree on that? After I do that, let's show. Up here, you're gonna have to look through. After I do that, right here, get the 10 on the other side, get the minus signs rid of, and you're left with that. That should be your matrix. Out of curiosity, how many did this right here? Did this right in this one? I'm hoping a lot of people did. That's the first part. Now the second part is I'm going around this way. So it's going to be minus, and it's 2 plus 2 is 4, right? Because they're both in series. Minus 4I2 minus V2 is 0, correct, class? Then you can get rid of the minus signs right there. You all agree with me? It's the same problem as before. The only thing that changes there's no capacitive reactance. It's strict real. They're the same exact topology of the problems. Now I get, when I do that, I substitute in what V2 is in here for V2, and I get this, and then I organize and I get this. That's the second equation. So your matrix should look like J plus 1, J, and 4 plus J2, I1, I2, 10, 0. At that point, I simply solve for I1 and I2. For I1, I get this, right? Correct, class? Now the I2 I get, it's not listed here, but the I2 you're going to get when you do this right, you're going to get an I2. If I2 is going that way, you follow me? Because I didn't ask for that I2, I asked for V0. You all see this? So whatever I2 is, if it's correct, I can say my V0 here will be equal to minus I2 times 2. You all see that right there, class? How many see that? Right? Because the current's flowing, it's flowing in, or it's flowing this way to develop a plus to minus kind of polarity. You all with me? All right. That's the first. Next problem. This is the one, the op amp problem. This is a stand kind of thing that you've got an op amp, you've got 2 inputs, some resistors. Find the value of the resistor that will give me, find the value of R2 that will give me minus 3 out, right? Now, I want you to follow me on this, because some people did mess this up. It was meant to be extremely easy. When I'm doing this, I see that I see first of all that this is at 0 potential at the positive terminal. That was the key to this whole thing. Y'all agree? If I have 0 volts there, I have 0 volts there, right? Everybody. If I have 0 volts there and my current flowing there, and I'm just going to call it I1, I1 would be equal to 2 over 12K. Do you agree with me? Just voltage difference is 2, resistance is 12K, right? Right now I'm going to do this. That's the same as 4 over 24K. Do you agree with me there? I'm doing it for a reason. Everybody? Now, that's flowing that way. What about this? This has the minus first, right? So it's minus 1 volt here, 0 volts there, effectively a plus to minus 1 volt difference there, correct? That means the current flowing here, I2, and I'm going to call that I2 right there, I2 will be equal to, and it's going to be 1 over 24K, but it's going that way. Do you all see that? I want everybody to make sure they see this. So if 4 over 24K goes this way, 1 over 24 goes this way, it means this current has to be 3 over 24K. Does everybody see that, class? Y'all with me? It's just simple. Whatever flows into, flows out. That's the only thing you had to figure out here. So if that is the current right through that R2, IR2, then the voltage plus to minus, when I take a look at that, I know if that's 0 volts here and I want minus 3 volts here, right? Then this voltage difference is 3 volts. Do you all agree with me there? How many see this? Make sure you do, right? It's 3 volts difference. So now I'm going to say that 3 volts here is equal to, it's going to be the current through there, 3 over 24K times R2. You can see by inspection, the 3's cancel and you get simply R2 equal to 24K. Are you with me? That was the problem in a nutshell. It was simple. The same with the other one, and I'm gonna do the other one too. How many see this right here? Clear on it? Yeah, I mean, it's not meant to in any way, shape, or form to be tricky at all. It's just straightforward application of the principles. Find the voltage, right, at one of the terminals. From there, find the currents. The currents give you anything you want. I gave you the output voltage, you just find the resistance. So that's that one. For this one, the second one, identical template problem. Here I had 3 volts and 10K. So if I think about this, the current flowing there would be 3 over 10K. You can call it I1 if you want. Do you agree with me, class? Now, I have 0 volts here. That means it's 0 volts there, 0 volts there. And I have minus 3 volts on the other side. So it's a 3 volt difference over 20K. So flowing that way, my I2 would be 3 over 20K, correct? Well, I1 is 3 over 10K, right? Or it's simply equal to 6 over 20K would be I1, correct? I'm doing it this way so people can see it clearly. Everybody okay with that? All right, if that is I1 here, and I know that I2, 3 of the 20K flow this way, then the current flowing here is the remainder, 3 out of 20K, over 20K. How many see this right here? Again, same as the other. Now, that current, 3 over 20K, times the resistance, whatever that Rx is, has to be 3 volts, right? Because this is 0 volts, this is minus 3 volts right there. Right there, that's minus 3 volts. Means that's 3 volts, and you can see the 3's cancel, and Rx is just 20K. Okay, for both of them, there's the same template problem, there's no trick at all. Yes, sir?
I'm curious, that I2 is flowing out purely because of where the positive and minus are on
Yeah, the minus is minus 3 volts, right, and the positive of that power supply is in ground, isn't it? What?
No, yes, sir.
That's all it is. It's just like it's forcing the current to go towards the negative terminal, right? That's it. Okay. Next problem I'm going to do is this test first. This is one, and again, this is the snapshot problem right out of your book. I gave you this problem. So if you take a look at this, this is a delta, pretty obvious, and a Y, pretty obvious too, correct? So you put delta Y configuration. After that, I know I want to do one phase. So with one phase, I see this is the AB phase. I have 208 at 20 degrees, and that is a delta voltage. Does everybody see that? A delta voltage. I need a Y voltage. I've always told you to go YY, so I take 208 divided by square root of 3. That gets the magnitude down. It's about 120, right? And then the angle has to be, whatever that angle is, minus 30. So it's 20 minus 30 is minus 10 degrees. Now, this is the line from A to capital A. That's 0.4 and J 0.8, correct? Then the load. The load's already in the Y, isn't it, class? So you don't have to modify it. This is what your circuit looks like. I'm after this current IAA. IAA is simply going to be 208 over the square root of 3 at an angle of minus 10 degrees over the sum of the resistances, which is 8.4, plus the reactance, so plus J 6.8. And then finally, that will be IAA when you solve it, 11.12 at minus 49 degrees. Then I asked for VAN. I got VAN by just taking I, small a, large a, times 8 plus J6. Y'all follow me in this class? This is a straightforward problem. It was literally out of the book. We've done this one several times, this type of problem. And that was the answer for that one. For the other one, similar. The other one, again, is a delta Y, same kind of configuration. It's a delta here. The voltages are between A and B. And it is a Y, because there's a single point where all the 3 loads are together, right? Y'all follow me, class? So it's delta Y. After that, I know I've got to take this delta voltage and turn it into a Y. So I take 100 at 0 degrees, divide by square root of 3. That brings the magnitude down, right? And then I have to subtract 30 degrees, don't I? So that's the voltage. Then you take the line, which is 3 plus J2 here, and then you go from A to N here, and that's going to be 10 minus J8. Do you follow me? After that, I need that current. Well, that current's straightforward. It's this voltage over these impedances. So it's 100 over square root of 3 at minus 30 degrees divided by 13 minus J6. Agree, class? After that, when you do the math, This is what you get for IA, right there. All right? It's just a division problem. Now, I had VAB and it should have been VAN, because that should have been a neutral. So I gave you credit for either one of these should have been the same. The actual value for VAN, right here, it happens to be VAB shown, but it should be VAN, is going to be the impedance 10 minus J8 times IA. Do you all agree with that? All right. And that would be this value here. However, if you multiplied by the square root of 3 and added 30 degrees because you thought I meant VAB, you still got the right answer. And if there's any problem with that, you come see me. All right, I made allowance for that. That was my error. I meant to show VAB, but B wasn't shown, and it should have been then changed to VAN. So that's the answer on both of these. It was a straightforward problem, not in any way, shape, or form meant to be tricky. Now, the fourth problem, fourth problem was straightforward. Here you've got, I'm going to do the lagging leading problem first, all right? For this one, S total, and I'm going to write it here, would be equal to the first one. So let me just do this. This is going to have some angle theta 1, which is equal to cosine minus 1 of 0.8, and theta 2 is going to be cosine minus 1 of 0.6. I know that's leading, and that's the key to this problem. Agree, class? So now S total is going to be this, 36 times 10 to the third. Then it's going to be E to the J, and this will be positive, whatever this angle is. I want to say it's 26, but I don't think I wrote it down on this, but is it 26 degrees for this one, or 26, 29? 36. 30, the first one, point A is 36? 36 degrees, and what is this one? 53. All right, so it's going to be plus J, 36 degrees, plus, and that's going to be the second one, 18 times 10 to the third, and it's leading, so it's a negative angle. It's E to the minus J, and that would be 53 degrees. Remember, because S is V times I conjugate, right? So if a thing's leading, the angle of the current's ahead. When you conjugate it, it's behind. Follow me, class? When I get this right here, that's S total. Now, the way I tell people to do this, if we want the actual current in the line, right, what I do is take the total complex power divided by 3, because I have 3 phases. Now I have the power in just the A phase, if you will. Now I take that, and I know it's equal to IAA, which is the Y current, not the delta current, so I take 208 by square root of 3, right? That's the line voltage, is 208 by square root of 3. And then I say times IAA. I'm only getting the magnitude here, not the angle. Do you understand, class? So I can see that IAA magnitude will be this. Some of you just put S total times square root of 3 over 208. It's the same thing. There's a variety of ways to cast this, and it all gets the same answer. Probably some of you had it programmed into your calculator. It doesn't matter. That's how you do it. That's the magnitude. Now, the combined power factor, when you add all these things up, right here, you're going to get a magnitude and angle. When you actually take the argument of the total complex power, it'll be 10.35 degrees, and then when you take the cosine of that, you get 0.984. All right? Okay, it is straightforward. This is literally a template problem out of the book that I took. I wasn't trying to be in any way, shape, or form unfair, and it was a very, in my opinion, very easy test. Yeah?
Could we possibly lose the point if we didn't write whether or not that power factor is leading or lagging?
You can show me your test afterwards, since I possibly didn't know how the grader did it. They have a more developed grading sheet, all right? Mine, if it says 0.94 lagging, you're right. It should be lagging in both, all right? And it should be. Now, for this one, here, again, same deal as before. Only both of these angles are now positive, and what's it? That's 36 degrees, you said? 53 degrees. These are both positive, so you have 36 times 10 to the third, E to the J, theta 1, which is 36, plus 18 times 10 to the third e to the j, 53. You have to add them. It's a complex numbers you're adding together. So then once you get this, you get S total. S total over 3, because you want one phase, is the complex power in one phase, is equal to V A N, or V small a neutral. So that's the phase voltage. You have to take 208 by square root of 3. That times IAA in magnitude will be equal, that's how you find IAA's magnitude, or IA is equal to S total divided by square root of 3 divided by 208, and get a value, and that value of line current is 148.551. And then you end up getting the combined power factor. So once you add these two up, complex, and you take the real part of it, or excuse me, you add them up and then you find the argument of that, you're going to get whatever that angle is, and I don't have it here, but you take the cosine of it and it should be 0.74. So one was 0.984, the other was 0.74, and these are all problems that you've done plenty of like. All right? Every single one came from the homework, and they were done over and over again in class. It was fair. If you have specific questions, please let me know. All right? Obviously, a lot of people aren't here today, and I'll probably, this is recorded, isn't it?
Yes.
And you were able to see that? Okay. So they'll have availability of the solutions online. This was not in any way, shape, or form a difficult test. For the final exam, the problems will be more complex because there'll be more elements, but the same basic ideas. All right? There's nothing that you're going to see here that on the final will look terribly different. You might have an inductor where a capacitor is, or where a resistor is, something like that. Do you follow me? Maybe two other components instead of one. But the complexity does not change in terms of some crazy circuit where you have delta Y's all over the place. It'll just be like this with these topics. What we have to cover yet, and somebody asked me about this, we're going to go through diodes. We're going to, if we have time, go through basic, bipolar transistor behavior and get really in field effect transistors. I think we'll be able to get both of these done, and then we'll have the final exam. All right? Okay, any questions? Have a great Thanksgiving. Do me one favor, drive very safely. Be careful. There's people drinking